All right, guys. Today in statistics, on Friday, March 27th, I've lost track of how many days we're quarantined now. We are going to work on solving logarithmic equations for x. We talked yesterday, we had that example about the age of a tree and its height, and we were solving for y and all that kind of stuff, but the last question said, how long will it take for the tree to grow to be 11 feet tall? Well, y was our variable for height, and x was our variable for age, so we have to plug in a value for y. That makes this a little bit more complex because we haven't done any problems like this yet where we solve for that x variable. So what I'm going to do is I'm going to go ahead and plug in the value for y and walk us through this problem. This will be, forewarning, a little difficult, and for those of you that haven't taken an Algebra 2 class or above, be a little strange. If you have taken the Algebra 2 class and you've worked with logarithms, the majority of what this is going to ask of you is just converting between logarithmic and exponential form. If you haven't been in one of those classes, that's okay. You may not as entirely understand what we're doing, but as long as you understand how we're doing it, you'll be able to successfully solve these problems. And I'll do my best to impart why we're doing this as well. I don't want to make you think that I'm just going to brush over that. So let's go ahead and substitute in 11 for y. So 11 equals 6.1 plus 6.1 times the natural logarithm, I accidentally made that look like an h, times the natural logarithm of x. Now, I like to write this in parentheses personally, because if you don't write it in parentheses, then it starts looking like that's 6.11, or maybe those are some variables, or what is it, So I like writing in parentheses to denote that it is a single variable. It is a single term. The natural logarithm of x is all together, and whenever we try to get x on its own, it is a matter of getting this entire unit on its own. So that's where I'm going to start. The recognition that not only do I need to get x by itself, but I need to get ln x on its own. So that means I just need to get rid of this point with that 6.1 and this one. So what I will do is take a look at this 6.1 and say, well, that 6.1 is multiplying, and the other 6.1 is adding. And apologies if you hear my dog whining in the background. She is in her very spacious room hanging out while I film this video so she doesn't jump up here, but she's not too happy about it. So as you guys know, with simplifying or getting stuff on its own, we want to deal with addition and subtraction first. So we are going to subtract that 6.1 to the other side, and we will end up getting 11 minus 6.1. I don't want to embarrass myself by subtracting in my head, but we do get 4.9. That's good, because my first reaction was 5.9. So we get 4.9 equals 6.1 ln x, and you see how weird that looks when we don't write it in parentheses? So that's why I'm going to put it in parentheses there. Now, we're going to get rid of that 6.1 that is multiplying, so we will divide by it, like so. And when we divide 4.9 by 6.1, we end up getting 0.8. 0.80 specifically, but I'm just going to round that to 0.8 equals the natural logarithm of x. So this is where things get weird. We've gotten ln x all down to its by itself. The natural logarithm of x is on its own. But we do need to kind of separate x from that natural logarithm. While we couldn't do that before, we're at a point now where we do need to do that. So in order to do that, we are going to have to convert this from being written in logarithmic form, as it is now, to being written in exponential form. So that's going to be where we see some familiarity with logarithms through Algebra 2 come into play. So logarithmic and exponential form are written like this. So we have log base something. I'm going to make up a logarithm here. Log base 3 of 9 equals 2. This is an equation written in logarithmic form. That's just what it looks like. A logarithm asks, how do I compare the base to what I'm taking the logarithm of? And the answer to it says, well, that's the exponent that gets the base into that one, that turns one into the other. 3 squared is 9, right? This is logarithmic form. This too, even though it looks a little different, is logarithmic form. What I'm going to do is I'm going to rewrite this. I'm going to flip the sides of the equation to make it look a little more similar. The natural logarithm of x equals 0.8. But you may be saying, well, this logarithm down here, it has a base on it. It has that little number. It has a 3. The natural logarithm does too. However, its base is a little bit different. You know, sometimes when we don't see a base with a logarithm, it's considered base 10. That's called the common log. But this is actually the natural log. So it has a base of, get this, e. You may be saying, that's just another variable. We've gotten another variable involved here. But actually, that isn't a variable. That is a constant. On your calculator, you may have seen it before. Right here, above the ln button, the natural logarithm button, we have an e button, e to the x power specifically. That is what is known as Euler's number. We're not going to get too far into what Euler's number is, but Euler's number, e, is the base of the natural logarithm. We actually talked about e a little earlier this year in my math analysis class. I was getting ready to make that anecdote, that comparison, and then I realized we're doing statistics. But those of you in my math analysis class, you saw e whenever we were doing continuous interest formulas. But this is a number. Even though it's written as a letter and it looks like a variable, it is a number. So here's the deal. We said earlier that a logarithm compares these two numbers and says what exponent gets between them. Well, I'm sure if you guys were given the numbers 3, 9, and 2, you pretty easily could write an equation that said 3 squared equals 9, right? Like that's a simple mathematical equation that we all know is true. The base to the exponent of the answer to the logarithm equals what we're taking the logarithm of. So we can rewrite the natural logarithm equation very similarly. The base, e, to the power of the answer to the logarithm, so e to the power of 0.8, equals what we're taking the logarithm of, in other words, x. Just like so. And we can plug that into our calculator. So, as I said before, you end up seeing e right next to the natural logarithm button, right here on the bottom of your screen. So I'm going to go e to the x power. That lets me fill in what I want the power to be, and it's going to be 0.8. If I hit enter, I find out the answer is 2.2 years. Or 2.2 is x, right? 2.2 equals x. Now, if we wonder, does that make sense? We can look at the data set from yesterday. We were looking for when it gets to be 11 feet. Well, at 1 year it was 6, at 2 years it was 9.5, and by 3 years it was 13. We said it would be 11 at 2.2. That makes sense that our answer should come somewhere between these two numbers, somewhere between 2 and 3. So that's good. Our answer made sense. We presumably, and I can confirm we did, do this correctly. But this is how we solve a natural logarithm equation. So I'm going to do a couple more of these. I'm just going to make up some numbers and do a couple more of these to show you how this works and just kind of really hammer this in. You know, if we had the natural logarithm of x equals 5, then what we would do is we would say the natural logarithm is base e, so we can write e to the 5th power, to the answer of it, equals x. And then in our calculator, we would just type in e to the 5th and get 148.4. So there's a little bit of a jump there between 0.8 and 5, but yeah, we would get 148.4. I wrote that wrong. So whenever we have these natural logarithms, the way you write it is you just put an e with whatever answer we have here, and we get at that x on its own. A way to think about it is kind of like this. If you had 3 equals ln x, then you can get rid of that ln x by writing this to the e power. E to the third, by putting that e there, it cancels out the natural logarithm, and you have e to the third equals x. That kind of thing. We will go over a couple more logarithmic problems on Monday. I know they're not in your packet, but I will come up with a couple and we'll work through them. It was not my intention to only have one logarithmic problem in your packet, but it was a matter of creating these packets in the span of, a day while also teaching all my classes that last Tuesday of school. So I'll come up with a few more logarithmic problems we're going to do at the beginning of the week. And then after those, we're actually going to move into our next section or our next unit that is a little bit more statistics and experiment and data set based in terms of predicting what's likely to see and what's not likely to see in data. So with that, thanks for watching, guys, and I'll see you next week.